Hey everyone, in this video, I would like to talk about the area of convex quadrilateral using the diagonals. So here we go. I give you the convex quadrilateral, and that is going to be the diagonal, and this is going to be the diagonal. Right, so in order to get, let's just label A, B, and C, and D, we need to know about one of those angles. Okay, so here's what's going to happen. I can actually find the area of each triangle that you saw here using law of sines. So if you use law of sine, it becomes 1/2 times AB sine theta. That's the first one. If I mark it, that becomes the area of that much. And I can add it with 1/2 times BC times sine. Here's sine 180 minus theta. And we can mark it out, this one, and we have 1/2 times, that shall be DC or CD, sine theta, because that's the vertical angle of theta. And we get 1/2 times AD, sine 180 minus theta. Okay, so this is this is the area. We can call it as capital K, but since we're just deducing the area of this figure, well, here's what we're gonna do. We understand that sine 180 minus theta and sine theta, they're in fact equivalent values. So instead of just writing sine 180 minus theta, we can actually write it down as sine theta. So 1/2 and sine theta are the common terms. So we in fact we get 1/2 times sine theta, and we get everything about AB and BC and CD and AD. Right, so let's just try to write them down. AB plus BC, CD, and AD. Okay, so check this out. We have D, B, and B that are common to the first terms, and we have D and D that are the common those are the common terms for the last two terms. Right, so what do we have? We have 1/2 sine theta. Well, you can check that we can group B out. We can pull B out from the first two terms. I can write it as A plus C. And I can also pull out D from the last two terms. And that becomes D times A plus C. Okay, so we get A plus C as a common term. So probably we can use the distributive property, or I would say factorization once more. So that becomes 1/2 times sine theta, and we get A plus C times B plus D. All right, so here's how we have deduced. I'm going to relabel A plus C as diagonal number 1. So that becomes D sub 1. And we can call B plus D or D plus D, doesn't matter in which order that we add, becomes diagonal number 2. So we get 1/2 sine theta times D1 and D2, which gives us the area of this convex quadrilateral, and we use it a lot in competition math.